Hello students, today's agenda is that you're going to get your grades from previous quarter. We're going to go over the syllabus and we're going to learn about basic figures and you will be able to do 9.1. Today students will be able to define and label the undefined terms, basic figures in geometry. What? Define undefined? Okay. Okay, so I'm going to ask you that you create a table that looks a little bit like this. And I did it sideways for the paper because I'm writing a little bit bigger. But if you want, you can write it smaller and going the other direction. Or you can just do one using this dimension as well. Okay, so the first figure that we're going to learn about is going to be something like this. So what would that be? Well, we can say that that's point C. Okay. And the description, we say description because there is no definitions for the first couple of figures that I'm going to show you. There is just not possible to be defined. And so a description, we can just say that it's a dot. Okay, a dot. The dimensions, well, there are 0 dimensions, and there is, for the measurement, there is none. You cannot measure a dot. Okay, and some real world connection would be, I'm going to give you some examples that my students gave me in class. So they said a decimal point, okay, a decimal point. They also said maybe a star, like if we think of space, a star would be a point. On the map, a house, okay. So these are some examples. They even said the letter I's little dot on top. That would also be something very specific. And they also said the beginning of something. Like if you think of it in a very different way, like an event. An event in time, like when that moment happens, that's a point. The next figure that we're going to learn about is this figure right here. And so this is A, and it's capital. A and B are capital because they're the names for these 2 points. And this is L, okay? And so the label, we can say that this is line L. But if we want to name it or label it by its points, we can also say line AB. Notice how I'm using a big sentence for this symbol. This is a mathematical sentence, but if you were to describe it in words, it would be line AB. But the same line can also be called line BA. Okay? And so again, this does not have a definition, but it can be described as points next to each other going on both directions infinitely. Okay, and that sounds weird. That description sounds weird. Why points? Well, if you think about it, if I put a point right there, and then another point right there, and then another point right there, and another point, what's happening? Well, they form the line, and you would just be extending the points on both directions, right? That's why they have the arrows, because they go infinitely. Okay, the dimensions would be one dimension, because you only have one dimension like this, going not directions, okay, but the dimension. And then the measurement would be length. That means that you can measure the line in centimeters, in meters, feet. So that's the measurement that you would give it. In some real world connections, some people say the freeway. They also said a river. And that one very interesting one that they came up with was life. We know that life started, but we don't know when it started. And we don't know when it's gonna end. Okay. I know that there are some scientific tests that allows us to see like when the dinosaurs were here, when different cultures were here, but in reality we don't know the exact time when life started. Okay, the next figure that we're going to define is a plane. And so maybe we can put A, B, C, D. And basically this plane we are using these letters to define it and be able to label it. But we can say that this goes on all different directions. Okay, so we can call it plane, or let me put in here maybe something like this, plane P, or we can call it plane ABC with 3 letters. It means plane ABC. Plane ACD, or maybe you can use to label a plane. You will need 3 different letters. You don't have to use all 4 of them, or if you want to, you can use A, B, C, D. Okay, you can also call it plane A, B, C, D using all the letters, or any combinations of 3 letters in any order. It doesn't matter. Okay, you can just use any 3 letters, or 4 if you wish to. The description is a flat sorry, not fat, flat surface, a flat, you could say figure, flat figure or surface, extending infinitely in all directions. And again, it's flat, so it's extending on its flatness. Okay, it's not like going in all different directions, 3-dimensional. No, it's just flat. And so from there it comes, for the dimensions, it's 2 dimensions, because you have this going in this direction and then going in this direction. So that's 2 dimensions, okay? So it's like this and like this, okay? 2 dimensions. And the measurement for something like this would be area, okay? And some real world examples, people came up with whiteboard. A whiteboard is a flat surface. They also said the top of the table. Somebody mentioned that before they thought that the world was flat. Then they thought that it was a plane, but now we know that it's as more or less, well, we can say that it's an exact sphere, because it's kind of a little elongated. What else they mentioned? The paper. Yeah, the paper, they said that it was also a flat surface. Walls. Okay, so these are some examples of planes. Okay, now we're gonna go to something different, and for the next one we're gonna have something similar. However, we're not gonna have a description, rather we're gonna have a definition. Okay, so you might want, if you need more okay, so the next figure is going to be in reference to a box. I have this box right here. Maybe I'll show you how to draw it, because I know some people have difficulty being able to draw this box. So the way that you would do it is you're going to draw a rectangle like this. Then I know that there are some people who like to draw another rectangle. However, for me, let's see, maybe just put it dotted up to this part. And then, so it's exactly the same rectangle, but a little, if you see, higher and to the right. So this is dotted, this is dotted. And then this is because it's behind the other part of the, this will also be dotted. Notice how these 3 lines are going to be dotted lines. And then the rest, you're going to connect it like this. Okay, so it's rectangle at the front, rectangle on the back, but the L, kind of the L, it's going to be dotted. And then this connects dotted, this solid, and this solid, and this solid. Okay. Excuse me. And then you just label it A, B, C, D, E, F, G, H. Okay. So that's the box that we're going to be using to be able to learn the other shapes. And I think I'm going to be, since I, sorry about that. Okay, so have that on the side, or have it, maybe put it just on the side a little bit. And so what we're going to learn now is going to be from this part, vertices. Okay. And we're not going to put a label. Vertices are just the, some people call it the corners. The corners. But that description, it says a point on a figure's extreme. Okay, a point on a figure's extreme. And so A would be a vertex. It's vertex A, or vertex, this is A, this is B, C, D, E, F, G, H. So vertex A, vertex B, we can also call them just point A, point B, point C, but we know that those corners where one or two lines meet in the box are going to be vertices. Vertices is plural, vertex is when we have only one. Okay, this is the definition. This is actually a definition, and we don't talk about dimensions because it's the same as the point. And also there is no measurement. Real world connections, the corner in a house, also when you have cheese, corners, the corners in there as well. So basically corners for the most part. Somebody said in a box, like where all the cardboards meet. Okay, so corners in a box. Okay. For the description, we can also put, so that we can remember, the tip. Not the tip like what you give to the to the waitress, okay, or the waiter. Okay, another one that we're gonna learn about is segment. And from this box, we can say segments AB. So from here to here, it's talking about this right here, okay? BC. So we're not talking about this segment right here. CD. Okay, right here. And then DA. Or you can call it AD, it doesn't matter. And a segment is actually a line, but it has two endpoints. A line with, oops, it goes right here. What am I doing? A line with two endpoints. And so for the symbol, you can also put a line. If you notice in the previous one, for line, you had arrows because it would go infinitely on both directions. In here, we have two endpoints, so we don't have arrows on top of this little symbol. Okay, so that's line segment AB, line segment BC, line segment CD, line segment DA. I don't know if you notice, there are 4 on top, there are 4 segments on the bottom, and then 1, 2, 3, 4 going up and down. Okay, so it's a total of 12 segments. Okay, what would be the dimensions would be one dimension, and it will be the same as the line length. What are some real-world examples? In the classroom, they said the table's edge, they also mentioned a ruler, although some say, well, that could be a representation of a plane because it has a little bit of width. Okay. Excuse me. Some people said a pen because it has a beginning and it has an end. Pen or pencil. Okay. Another real world connection could be, what did they mention? The measuring tape. They also said not a road like a freeway like before, but one that has a beginning and end. Those that are where you turn around the corner, so maybe like a drive. Okay, because those are shorter. That doesn't mean doctor, okay? Drives or small streets. Okay. We also have faces. And the faces again, oops, sorry. It refers again to, in the box, we can find the different faces. And faces can also be referring to planes, because we can see that on top we have one, on the bottom we have another one, that's two. Right and left, that's two. And then front and back, that's two. So basically we have a total of 6 faces in here, in this box. Okay, and again, because they are a representation of a plane, we can name it with 3 different letters or 4 different letters. So some examples would be A, B, C, or maybe, so A, B, C refers to the top face, right? D, C, G, D, C, G. Okay, what does that refer to? D, C, G. Oh, it's the one on the right. Okay, if this is hard to see for you, what I will recommend is for you to actually get a box, a small box, and put post-its with these letters, and then start saying, oh, ABC, and then just say ABC. Oh, it refers to this part. Okay, it's gonna be a little easier for you to see. Okay, E, F, G, E, F, G, E, F, G. Oh, it refers to the one in the bottom that we cannot see, and that's why we're putting these dotted lines. Okay, maybe another one could be ABF. ABF. Oh, that's the one on the left. Okay, the other one BCG. So BCG is the one in the back. Again, if this is hard for you to see, BCG is using letters that are for the top, for the left. I mean, if you look at one letter, that belongs to 3 different faces. Letter C belongs to 3 different faces. But if you are referring to all this group of letters, then it refers to the one in the back. And then finally we have ADH, ADH. Oh, all those 3 letters refer to the one in the front, okay, the face in the front. Okay, so in the definition we can just say that it's a portion of a plane. Remember that a plane goes infinitely, so that's why infinitely on all directions, so that's why it refers to a portion, because it's actually referring to that specific section. So sorry, a portion of a plane, usually on the surface of a three-dimensional figure. Okay, so dimensions, because it's talking about faces, is again 2 dimensions, and it will be area, because we're not talking about the whole cube, it's just the faces. So that specific face, it's a plane, so it's area. Okay, and if we think about it, so it will be the same thing. It's like one side of the house, one wall. So it's similar to the other in plane, right? So a wall, what else could we say? Well, we have some examples. Again, it will be similar to this. So a whiteboard, table, paper, walls, all of those would be examples of faces.